Welcome to JAM306, Protect Your Application with Secure Coding Practices. So, we've got a few more people in the room than we had in the earlier session, and we were just debating whether that's a fact that this is a more popular session or the fact that it's just a little later in the day. People have had time to sleep off the effects of last night's party. I hope you're all enjoying BlackBerry Jam. It's certainly been a great conference so far. So, we're here today to talk about how to secure your application, or the practices that you should be using to make sure your application is secure. So I want to take you on a little sidetrack. How many people have seen the BlackBerry advert that ran during the Super Bowl? Hands up. Okay, not too many. So it was only a 30-second slot. Cost over $2 million, so there wasn't a lot of time to get across what we can do in our brand new device, the Z10. So for those of you who haven't seen it, it was a guy walking down the street. He had a Z10 in his hand, and he was touching the screen, and all sorts of magical things were happening around him. You know, an oil tanker that was going to crash suddenly, when he touched the screen, suddenly popped into a cloud of rubber ducks. And the concept of the advert was, we haven't got a lot of time to tell you all the great things that the Z10 can do for you. What we are going to do is show you a few things that it will not do. So using that concept in a similar vein, I'm just going to let you know that we're not going to tell you exactly what you need to do for your application to be secure. We're not going to provide a magic potion that you point at your bar file and it suddenly becomes secure. We're just going to talk about the practices that you should think about, give you some seeds of thought that you go back to your day job with, and hopefully use some of that advice to ensure that your application is secure. So my name is Jason Foy, and my colleague Barry. We work within the BlackBerry security team at BlackBerry. I'm a security product manager. And my role, basically, as well as managing a product, and the product that I manage is BlackBerry Balance. So if you have any questions on BlackBerry Balance, come and ask me some questions at the Ask the Expert section later on today. I'll be there. And part of my job, as well as managing a particular product, is also to work with many other product managers within BlackBerry. There are lots of different product management teams: hardware, software, networking, various product management teams within the organization. So we work with those other product management teams to ensure that they are thinking about security at all times for the whole software development lifecycle. And one of the key takeaways that I want to give you today is that the earlier you begin thinking about security, the cheaper it will be for you in the long run, the better it will be for your application. So I'll hand over to Barry and let him introduce himself.
Yeah, I work in the security research team, and my role is mainly working directly with developers. So when we have the security development lifecycle activities going on, I support them with the design of their application, with the coding of their application, and then the implementation details and the vulnerabilities that they find. So if one of our developers has a coding vulnerability and they don't quite understand how to fix it, then I can sit down with those guys and work through it with them and give them the technical input that they need for the vulnerability. And then the second half of the presentation, we'll look at some real-life vulnerabilities that we've seen in our products and in public products, and how we tackle them.
Thanks, Barry. And as you can see, we've got a number of teams under that BlackBerry security umbrella, so security product management, security research group. We have a response team that handles the public responses to any vulnerabilities. And we have security certifications who work with the various organizations around the world to help get our products certified by the various regulatory bodies or governments. So today we're going to discuss secure development life cycles. We're going to try and help you think like an attacker. A lot of developers will start coding their application, and they want to think about how the user's going to use the application. So, what's the best user experience for the user? They don't necessarily think about how a malicious user would misuse the application. And then we're going to talk about threat modeling and thinking like a defender. So, what you need to do is adjust your development model, embrace security within your development model. whatever model that you use, whether it be waterfall or agile with Scrum methodology, none of them implicitly create secure software. You need to think about security throughout the whole life cycle of your development life cycle. This is a very simple diagram, but it illustrates one of the key points that I spoke about earlier. The earlier you begin thinking about security in your application, the cheaper it is in the long run. If you build security into the requirements, which is part of my role within BlackBerry, as we build out the requirements for a new piece of software, we're already beginning to think of security with that product. And the further you get down the product life cycle towards release, the more expensive it is to deal with a major issue that comes up. You know, up to the point of either delaying the release of your software or having to pull the software after being released, which is obviously a very embarrassing situation, very costly too. So the earlier you begin thinking about security in the development life cycle, the cheaper it will be. So why bother with security? Well, from BlackBerry's perspective, we're always thinking about security. Security is a benchmark in our product. It's similar to software quality. Pay now or pay later. Do you invest time, energy, and resources, and money, obviously, into thinking about security early on, or do you deal with it after the fact that something's happened? Security is something that goes unappreciated within many pieces of software. Security is only really valued when something goes wrong and an exploit has happened, which is going to cost a company money and various other aspects of quality, reputation, branding, impact. All of those things are going to cost you in the long run if an application is exploited. Increasing connectivity creates more trust boundaries. These days, the devices that you have in your hand have many, many different ways of connecting to the outside world. So not just cellular, there's Wi-Fi, there's Bluetooth, NFC, various connectivity methods, and this creates more opportunity for theft. And security is a quality metric. It enables software reliability as well. The more secure your software is, the better your reputation is, and the more likelihood of customers buying your software. So you need to ask yourself, what assets does this software need to protect? If you're working within the financial sector, you'll be dealing with customer data that's very sensitive. Financial details, credit card numbers, that kind of thing. User data, name and address. Name and address details can be used by criminals to extract money from various sources. Account numbers, access to paid services, very popular now to buy applications, to buy products online. Privileged access to the device. Does your software have heightened permissions? Does it run with more permissions than it needs? And control of the host. So vulnerabilities sometimes utilize vulnerabilities to take control of the host and do things like start dialing premium numbers in the background without the user realizing. And then ask yourself, how might an attacker access these assets that your software is managing? There's various methods: eavesdropping, unexpected inputs, other applications. Can other applications access the content and resources that your application manages? And of course, device theft. And then you've got to think about the security that you implement. Is it appropriate for what you need it to do? Does it do the job? And this is a good example. Somebody's gone to the trouble of putting a security barrier, a little post there with either a card reader or an intercom to talk to security. And as you can see from the tire tracks, nobody bothers to use it. So without the appropriate fencing alongside that road, this is useless. What's the point in having it there? What's the point in spending the money to put it in if people just go around it? So is the security that you implement appropriate for what you needed to do? It could be. It could be. The gentleman's made the point. It could be a trap to see if people do go past the security. So when to care? and obviously, being BlackBerry, we think always. Security is one of our core principles in our products. We perform risk analysis. We use a method of scoring new products. We have product managers submit a request for an assessment, and we have a set number of questions that we run through. And each of the answers to those questions is scored. And at the bottom of the spreadsheet, there's the total score. Depending on that score, depends on whether we push this application for further assessment. Do we push it to code review? Do we do vulnerability assessment? Do we do exploit assessments? Do you connect to the internet or other networks? How do you connect? Do you connect in a secure manner? Is it open? What's your target audience? If you're working with the healthcare industry, for instance, you're going to have possibly going to have confidential user information, medical history of users, of patients, sorry. Financial sector, you're going to have very confidential information about users. And what coding language do you use? Do you rely on a managed code that has already been tested fully, the known exploits have been covered? Or are you using a language that is not tried and tested, and you have to manage a lot of the security of it? So do you fall back on the industry standard code, or do you go open source and worry about the exploits yourself? An industry example is Microsoft Internet Information Services. So in the early 2000s, it was widely criticized. It had a lot of vulnerabilities. And at the time, I was actually working as a server administrator for a law firm. We had a lot of servers running NT4, Service Pack 6A. IIS was just in the early days. We didn't tend to patch servers very often. We'd install a server, it would be up and running. It could be up and running for 6 months, a year, before it was taken down for maintenance or updates. So it was widely criticized for the number of vulnerabilities and poor security. Microsoft actually implemented a secure development lifecycle. They started thinking about security during the course of writing the IIS. Part of that secure development lifecycle is the post-release patching, the response side of releasing software. They introduced in 2004 the concept of Patching Tuesday. The second Tuesday of every month, they would release a set of patches. My job became assessing those patches and making a recommendation to the firm about which ones the various server administrators around the world needed to install. And once Patching Tuesday came around, by the end of that week, I'd make the recommendation, and then the following week, the servers around the world would become patched. That was a new concept. And I personally think that the incident that made people realize that patching servers needed to be part of their job was SQL Slammer worm, which hit in 2003, actually 10 years ago. It was a patch. Sorry, it was a worm. It was a very simple concept. It would propagate itself to a number of random IP addresses. It caused network overload. It shut down a lot of the offices in our firm. And the crux of SQL Slammer is that there was actually a patch available that plugged the exploit, and it had been released 6 months before SQL Slammer hit. So some offices were okay because off their own back they had started patching their servers. A lot of offices were taken down completely. Literally had to unplug the network to the outside world, fix the problem, patch the servers. And it wasn't just the servers. The vulnerability existed in the desktop edition of SQL. So any accountant or lawyer who had bought an application, installed it on their desktop, and was running the desktop edition of SQL were also hit. So patching is now a regular maintenance schedule in a lot of companies. And they spend a lot of money on solutions to automate the patching, various patching solutions out there. And by 2006, Microsoft experienced a 50% reduction in vulnerabilities on Microsoft IIS. So development process goals. You know, what are you trying to do? You're trying to create good software quickly and reproducible. You know, you don't want to be writing new software from the ground up every time. You want to be able to produce software quickly, cheaply. You want to reduce the chance that the design teams, the developers, introduce a defect or a security hole. You want to let developers get on with writing new applications, new cool stuff. Limit rework, limit patching, limit pulling products from the market after release. So areas of focus. Education is one key point. You need to educate your developers. Have them think about security early on. You need to build security. You need to build requirements into. Build security into the requirements phase of your application development. When you're first trying to address a need, you know, your customers come to you and say, I want an application that does X, Y, Z. You start writing the requirements, thinking about how you're going to do it. You need to think about security early on. Architecture and design. At BlackBerry, during the architecture and design phase, we have a security presence in those meetings. And throughout the whole architecture and design process, there is somebody there who advises the development teams, the architects, makes them think about security at all times. You know, your application is going to do this. Well, what about if an attacker took that and did this? You need to plug that hole early on. Code. Obviously, code reviews within BlackBerry happen all the time. You know, Barry's team will take a look at the code of an application and look for holes. And part of my job is to do bug triaging. And whenever I get bugs that are logged by Barry's team, they've dug into the code and they've found a gap. And then we need to work with the development teams to fill that gap. And response. You need to be able to deal with security issues after the product is released. You need to work with your customers to be able to fix those post-release if they do exist. So thinking like an attacker. So avoiding thinking in relation to security is the top section of this slide. Developers may sit there and think, well, no one will ever do that. No one will ever find this hole. I'll just ignore it. Why would they be doing that? Why would they look there for a hole? And stored data is safe. Is it? If it's on the device and there are other applications on the device, can those other applications access the content that your application manages? Sorry?
Yes, they can.
Yes. Gentleman made the point that it's, sorry, on the...
This was classic in Symbian, the attack that they used, that they took out the memory card of the program and then they analyzed the content of the memory card.
Okay.
It's classic.
Okay. So the content of the memory card was analyzed in, did you say Symbian?
Yes, it was a classic attack of Symbian application.
Okay, thank you. So what we tried to promote is the bottom half of this slide. Always think in relation to security when you're writing applications. How could this feature be misused by an attacker? Do I trust the source of this data? Is this asset a secret, going back to your customer base? You know, Is your application appropriate for the industry that you're working with, the content that you're working with? Does this asset need to be integral? Some of the questions that we ask during our assessment of new products are, does my application use external data or services? Is it connected directly to the internet? Or does it go through other channels that are secured in themselves? How does my application process data? How does it store the data? What can interact with my application and its content? And how does my application handle failure? If your application crashes, does it leave exposed data that a malicious user could use? So secure design, you need to look at the attack surface. You need to think about defense in depth, and Barry's going to talk about this a little bit more in depth. And you need to minimize privilege. Does your application need to run with the permissions that it does? Could it operate effectively with less permissions? I'm going to hand over to Barry now, and he's going to take a bit more of an in-depth approach.
So we've got a couple of examples now and some common issues. And I know that you guys are a mix of different developers, different platforms. So these vulnerabilities are things that you could find in pretty much any platform. So if you were using C++, you would have all the native coding issues and so on, very specific to your platform. But you would also have logic issues, authentication issues, things that affect a number of different platforms. How does this thing work?
Right hand button.
There we go. So these are a short list of some of the security vulnerabilities you could have. There's far more than this, and you won't have all of these in every single application. If you don't have SQL in your application, then SQL injection is something you don't have to worry about. But encryption and authentication and things like that, you generally have to worry about them in pretty much any application that you're building. So if you have a device application and it connects to a service, you're going to have authentication worries. You're going to worry about, is it the device or user, the legitimate user that's connecting to my machine, or is it a bad guy that's trying to access our data? But you also have this the other way around. It could be that the device is connecting to a malicious server. So you need authentication in both directions. Generally, you find that SSL in one direction and a password or something like that in the other direction, but you could have mutual SSL authentication in there as well. So how do you design that? What do you do? Where do you come up with the requirements? And the way we do it is we take each of the components and we kind of break it down and think about the options that we have. So if you have an authentication system, maybe there's a brute force attack. Maybe someone can figure out the passwords by continuously logging into the system. So what are our options for protecting that? How do we stop it happening in the first place? So let's lock the account if there's too many logins. I'm not a fan of account locking. I consider that denial of service. So I prefer rate limiting, where instead of locking the account, you make it harder to brute force because you increase the time to respond after each attempt to log in, which kind of targets the user. It's attacking the device, but doesn't prevent the legitimate user from then logging in later on. Obviously, strong passwords help, and CAPTCHA. Can I show of hands if you know what CAPTCHA is? Okay. Show of hands if you've had to read those silly images that Yahoo or whatever puts on. Yeah, that's the thing. Those are pretty annoying. I don't like using them. They work fairly well if they're designed well, but they're quite annoying to use. Does anyone know what it stands for? Turing test. Yeah, it's completely automated public Turing test to differentiate between computers and human and automation, or something along those lines. But it's a pretty convoluted acronym. So once you've got past that point, once someone's actually attacked it, how do you identify it? How do you know that someone's trying to break into the system? And one of the options that you could have is unsuccessful login accounts. You can also do other things, looking at number of connections from an IP address and so on. But you have to be very careful if you have if you do IP address related stuff, especially on mobile platforms, because many devices will share addresses because they go through a corporate server or something like that. So we're very careful on how we handle those. And then how do you respond to it? How do you log the information? How do you let the user know that someone's tried to log in? I know if someone tries to brute force into Facebook and then you log into it later on, it will tell you you've had so many unsuccessful login attempts from this machine that you don't normally use. And then you can alert administrators and let them know about the issue. And then how do you recover from it? So this is the one area that we find most lacking in our developers. They get all the way up to response, and then we say, well, what do you do next? When it's completely failed, what do you do? And in this case, password resets and things like that are the way to do it. And we'll look at some other options for recovery in some of the later vulnerabilities. So this is just brute force, right? You've got other authentication issues that you could have, and you would do the same thing for each one. You could have a logic issue, which we'll look at in a bit in your authentication. But once you're authenticated, you also have the authorization problem, and they're two different things. Authentication is identifying who you are, and authorization is identifying what you're allowed to do. So imagine a web application where you log in as admin and you have all of these functions. This is a vulnerability that I've seen numerous times in our code that we've written, and in my previous job looking at web applications in general, where you have an admin page. It's admin.jsp or admin.php, and it has all these extra functions in there. And when you log in as a user, it just hides that from you. It doesn't give you the link to it. But if you browse to the page, if you know where it is, if you know it's admin.jsp, then you get access to all the functionality. It doesn't actually block you from doing it. And another common issue is you can't get the page, you can't load it. But if you know the details of the post request, you can send the post to the page and it will still work. So when you're building something like that, you have to be careful to make sure that when you're logged in as a user, you completely disable it, you completely remove the functionality, and you don't get access to it. I found the first time I ever found a vulnerability like that was a way back in like 2001, and I'm still finding them today, this week, in code that people write, because developers think if you hide it, the user won't know it's there. But if you've installed the software on your own laptop as a test system, you know where all the admin functionality is, right? So when you're looking at someone else's installation, you can find it if it's not protected. So how do you prevent vulnerabilities like that? What do you do? So your threat's unauthorized access. You don't want someone accessing something that they shouldn't. So how do you do it? You have strong authorization checks, and that's quite woolly compared to the login one. The login one was pretty concrete. You can tarp it, you can lock people out. With authorization, other than checking that they're authorized, there isn't really a lot that you can do to prevent them, gaining access. They're either authorized to do it or they're not. It's a very binary decision. And how do you detect it? Well, the only way to detect authorization issues is to browse to the page, send a post request. You've got to go and test it. You've got to negative test rather than positive test. You've got to find out if it's possible to do this stuff. And then how do you respond to it? Well, you panic. someone's broken into the system. Someone's got access. You need to lock it out. You're unplugging cables if you've got viruses and worms attacking it. And then fix the vulnerability. If your authorization checks don't work, get that fixed and get it out quickly. If we have a vulnerability like this in a product that's already released, then we have a very strong push with the development team to get that vulnerability fixed as a priority and get it released. We may have to wait for a maintenance window. We only release BES updates every so often, so we can't release a security update today. We may have to get it in. But my job is to push that as much as possible and get the fixes into the product. If we find these vulnerabilities before the product goes out, that means I've done a good job and we've caught it early, and the developers have done a good job. They've worked with me. It's not a problem. We can get it fixed before it goes out the door. So my team spend a lot of time doing that sort of testing, looking at the applications. We have guys that just do web application security, so they will just hammer web apps all day long and look for ways to break into them. And then how do you recover from it? You want to have backups, resiliency, all your standard resilience techniques is what kind of comes into effect once you've lost you've lost the access, you've had the attack. So try and restore from a non-good set of code. This is another fairly common issue. We see lots of logic issues. Logic issues are my favourite type of vulnerability because when you write your code, you write what you want the code to do. And when you read that code, you read what you want to read. You don't always notice that there may be a vulnerability. Can anyone see the vulnerability in the line of code at the top? Sorry? Well, this, imagine it's in a network service, so you're attempting to log into a network service. But yeah, if it was a local machine, there's an issue with the logic here. This code will stop you from logging in if your account is expired and your account is locked out. But what if your account's only locked out and not expired? Exactly. The bug's here. It's the wrong logic operator. And that's quite hard to see. No one caught that. Well, one line of code there. Imagine this is hundreds of thousands of lines of code, and you've written this code. That looked to most people looked like it was good code, but it's not. You want it to be this. You want to lock people out if the account lockout is set, or if account expiry is set as well. So you can see it's really difficult to find vulnerabilities like that by reading your own code, because you expect it to do one thing, and you kind of read what you want to read. It's like proofreading something you've written in an email, and you've written the twice, and you don't see it because you read it very quickly, and you read what you expect to read rather than what's actually there in the code, which is why I don't write any code for BlackBerry. I'm not a developer. I'm just an attacker. So I don't have ownership of the code. I always come in as someone that wants to find the vulnerabilities, that wants to break the code, keeps that level of separation so I don't get into the developer assumptions. And when you start assuming things about the code, that's when you have lots of vulnerabilities. I have an example of a real-life bug. I think this is about 6 or 7 years old now. And again, it's a logic issue, and it's one of my favourite vulnerabilities because it really shows how this stuff can work. So hands up if you know what VNC is. I'm sure plenty of you guys have used it. Yeah, it's a remote administration tool for anyone that doesn't know. So you get a desktop view of the software that you log into, and real VNC is just one of the products that does it. There's like Tight VNC and Ultra VNC and a whole bunch of others that do it as well. And what I've got here is a simplified version of the protocol, how it works. So it's kind of set up as like a chat. You've got the client chatting to the server, and the client connects into the server and says, "Hi there, I'm a client. I would like to authenticate with you. Let's do remote desktop." And the server says, "Okay. You can authenticate with me. You have a number of options." It supports more options than this, but this server has been securely configured, and the administrator said you have to enter a password or use a key or use integrated Windows authentication to log into this machine. And the client says, "Okay, I'll pick one of them. The one I've chosen is no password, which isn't on the list." So the bug in VNC was that the server was configured to have multiple options for login. But if you disabled the options, all it did was change the code that sent the options out. But if the client just ignored that and chose the non-passworded option, it could get access, it could log in. And this wasn't found by code review, and it wasn't found by a hacker, it wasn't found by an attacker like me, it was found by a developer. He was writing code. He wanted to write his own VNC client. And if you're writing a piece of software, you start with the easiest implementation first, right? So the easiest thing to implement would be no password. You don't have to worry about keys and things like that. So that's what he did. He wrote up some code that connected to his test VNC server, and his test VNC server was set up to allow no password login, so everything was working fine. So he tested it, and the desktop popped up, and that was good. But then he noticed that he was looking at his production desktop, not his test desktop. He'd put the wrong IP address in, and he thought, "Oh, yeah, that was a bit silly. Hang on a minute, how did I get into my production server? It's supposed to be password protected." And then he looked at the code for VNC and then identified that that's where the vulnerability was. And that had been in VNC for years, and no one had found it. And basically, if you had a VNC server sitting on the internet, And I've had that, and before I've had a key, mine was protected by a key, and I thought, yeah, I'm secure, I'm all about security, we're sorted here. And I was completely vulnerable, and I got pretty unhappy when when I heard about that. So if you expose something like that to the web, just because your password protection is good, your authentication is good, your authorization is good, it doesn't mean that there's no way in. There's always issues that you can come across, and they can be in the code for a long time, kicking around there. And the reason I use this example is because I've seen in BlackBerry products internally very similar things to this, in stuff that we've caught before it's gone out. And hopefully there's none out in the wild like this, but hopefully we've caught it before it gets there. But again, it's a common issue, and it's logic. It's all logic based, and you can have this vulnerability in Java code, C++ code, web code of any kind. You could have it in pretty much any type of application. It doesn't matter which language or framework you use. So how do you protect against logic vulnerabilities? What do you do? So the threat is on an unexpected application state. If you look at those two previous issues, they were unexpected states to the application. How do you protect against that? What do you do? Well, code review and negative test cases. You need to look at the code, and you need to have it looked at by independent eyes. You're looking at your own code. You won't find these issues. You won't see them. You might catch some of them, but you're going to make assumptions about your code. One of the things I tell our junior security researchers is never read comments. Don't read comments in the code, because comments tell you what the developer wants the code to do, not what it actually does. Just read the code, stay away from comments, except comments that start with XXX or bug. Read those ones. But all the rest of them, don't read them. One of my techniques for finding vulnerabilities is to just grep code for XXX, hack, and bug, and I get issues in code almost every single time by doing that. It's fantastic. So if you put that stuff in your code, guys like me will be looking for it, we'll find it. How do you detect it? Well, it's unexpected state, so that's very difficult to detect in the first place. You could have a state checking routine, but that gets really complex. If that's running in the background checking that variables are not set and are set and so on, if you've got a complex application, that gets really hard. So your best line of defense for this is to have the negative test cases, try out the functionality, do things that the application shouldn't really do. And then, again, lock it out, fix the vulnerability. I think I say that phrase about 50 times a day. Just fix it. Just fix it. Put it in the code. Fix the vulnerability. That's the response. And yeah, backups. Make sure your resilience is in place. Make sure you have a good set of protection for when it does go wrong, because it will go wrong. There will be vulnerabilities. We have fairly secure software, but we still have a security response team. We still get vulnerabilities coming in externally. Software development is complicated, so even the best code that we have still has issues in it. You can still find them. So be prepared. Be prepared to fail. Know that your application will have issues, and have a plan. So you can do something about it. And our response team have a very strongly developed plan for each of our products, and it's different per product, because each product develops differently. We've got agile guys and so on. So we kind of fit it around what they do, but every team has a plan. So the best team, we know when they release, we know when they can put fixes in. We know BES relies on Java, so we have to have an update mechanism for Java. If you've seen any of the security news over the past few months, you'll know that Java's been a complete nightmare security-wise, to the point where Apple completely disabled it on their OS because it was just too insecure. If you use Google Chrome or Firefox, you'll get and you try to use a vulnerable version of Java, it will tell you at the top, this is vulnerable. Do you still want to do it? And all of you guys probably click yes, just like me. But yeah, I just want to get into this WebEx meeting. I don't care. Let me in. But yeah, so you've got those options there. You can put things like that in, and you can do that with your code as well. And then you have all the data problems. And I think one of the questions earlier was, is the data secure? And the guy at the front said, no, it's not. We can pull the card out and have a look at it. Data at rest is the stuff that gets dumped on Pastebin. I've had my details dumped on Pastebin from LinkedIn, from I think Sony, from a few other places as well, because their databases got hacked. And my email address and my password hash were pulled out and stuck on the web for everyone to see. And there's probably a few of you guys in the room that have got your details out there. And if you're not aware of this, then go search for some of these hacks. Search for your email address online, and you'll find the databases that have been dumped. You don't want that to happen to your application. And if it does happen to your application, you want to make sure that your data at rest is protected, because it has a high reputational impact. When that stuff hits, it hits big. And we're security branded as a company. You know, we have it as one of our key cornerstones of what we do. Whenever there's a vulnerability or something in a RIM product, or if we lost a whole bunch of customer data, that would have a strong reputational impact on the company, and that costs more than any development effort to put that fix in or to get the vulnerability out. The reputational impact is the main thing. And if you guys are building like a financial application or even a game application, you don't want your users to dislike you. You don't want them to be unhappy because you've released their details to the web. So what do you do about data at rest? So your threat's on unauthorized database access, or your threat could also be pulling a card out from the device. If you're storing stuff on a memory card, how do you protect it? But in this specific instance, we'll look at unauthorized database access. And what you want to do there is make sure that you encrypt it where possible. You use password hashes, and even using a password hash isn't very simple. It's not a case of, yeah, we'll just use a password hash. It's got to be a strong hash. You don't want to be using one of the outdated algorithms. You've got to salt it, because if you don't, it's vulnerable to rainbow table attacks. So each one of these options has its little tweaks that make it more secure or less secure. If I'm looking at a piece of code, one of my other techniques is to find the encryption code and look at it and what it does. And I love talking about cryptography, so if you've got cryptography interests and you want to chat to me later, then by all means. And the common issues that we find there are you're using a weak hash. This is outdated. Replace it with SHA-256 or whatever our minimum level is. We have a developer guidance note that tells you what the minimum level is for BlackBerry products. So to release a BlackBerry product, you must have a hash that is as strong as this hash or better. And to encrypt data, personally identifiable information, you have to encrypt it with encryption that's at least this good. We have this minimum standard that you have to hit. And you'll see that in our implementations on our BES services, on our devices. They all hit that standard. They may use different algorithms, but they all hit the minimum standards that we set. And that information is available to our developers. We kind of shove it down their throats whenever they're doing anything encryption related. And I'm constantly emailing those documents and sending them the links and saying, have a look. Do it right the first time, because if you get the wrong encryption in place and then the product goes out, it's a nightmare to fix it, because you've got backwards compatibility, and how do you unencrypt the stuff that was already encrypted previously, and it becomes really hard. Then you've got operating system protections. If you're building an Android application or a native application, you've got sandboxing capabilities, you've got application permissions, you've got file system permissions, and those are similar on the device platform as well as on Windows or Unix or Mac or whatever. You can put similar protections in place, and then the database itself might have a permission model. I did a lot of work with Microsoft on SQL Server, and they have a fine-grained permissions model now in it, and you can lock down, even when someone has access to the database as a web application, they can't add users and run XP command shell, which used to be my favourite part of SQL Server, and drop themselves into a command prompt on the machine. So you can lock the database down like that. If you're using something like SQLite, then you want to make sure that whatever you're putting in there is protected, because by definition SQLite is generally used on data that's it's kind of part of your application that can be easily pulled off by a user. You're using it for your configuration and so on. So protect it using whatever options the platform has. And then how do you detect it? You have audit logs. Databases have extensive auditing capabilities. So use that. If this is your back-end system, then have an audit set up. Know what your database is doing. Know what normal behavior looks like, so that when it gets a little bit abnormal, you can find it and you can see what it is. Use an intrusion detection system or an intrusion prevention system that suits your goal. Don't just install it because you need one. Don't just stick Snort on the front of your web app and think that's it. Install it intelligently. Install it to do a specific function, and read the logs. I did a lot of consultancy for large clients, and one of the first things we do is go in and look at the logs. And we find that we don't need to find vulnerabilities. They've been hacked already. They've already got someone in their system, but no one's looked. No one knows. No one's seen the evidence that these guys are there. So how do you respond to it? Customer notification. There's laws coming out in various states. I think in California were the first to have a notification law for security breaches. So if you expose data from someone who lives in California, then you have to let them know about it. So how do you do that? What's your response? And then do you have compliance issues? If you have a vulnerability and you take card payments through the PCI scheme, then have you now failed PCI? Do you have to go through another audit to get security accreditation again, so that MasterCard and Visa will play with your application? And then database recovery, backups. How do you get same again, backup plan? How do you get everything back up and running? And then beyond the data in transit, you've got beyond the data at rest, you've got data in transit, data that's being passed across the network. If you're developing for the BlackBerry 10 platform, you've got multiple communication options. You might be going over a VPN, you might be going through Wi-Fi. How do you protect the communication at that point? And if you've seen, I'm sure you guys will have seen at least Wireshark and TCP dump, which are network diagnostic tools, to sniff the network and see what's coming across. And then Firesheep, my kid could hack with Firesheep. You just install it. Hands up if you've seen it. Okay, okay, I'll explain what it is then. Firesheep is basically an extension for Firefox, a native extension for Firefox that sniffs the wireless network. So if you installed it here today, and all the people that are using wireless devices that are logged into Facebook, if they're not using SSL, it'll show you the name of the person in the Facebook picture, and it'll steal the login credentials for you. And when you want to log in as them, you just click on their name, and you're logged into their Facebook account or their Twitter account, and you're hacking away. Download it and have a look. It's fantastic. So anyone can use that. You don't need to be technically skilled to use that. If you can install a Firefox extension, then you're a hacker. You don't need to look at code. You don't need to look at logic. You don't need to look at ands and ors and so on. You just need to install this tool. And then you've got slightly more sophisticated attacks like SSL strip, which weakens your SSL connection. If your SSL connection isn't strong, you can use SSL strip. So I'll explain how that can work in code. And this is a common issue that I've seen in BlackBerry code and in code in previous lives. You have SSL. A client connects to the server. It's presented a certificate, and you've got a secure communication channel, right? But the client's not actually checking the certificate. It's not checking to see that it's signed by a certificate authority. It's not checking to see whether it's expired. It's not checking the common name matches. It's not checking any of these things. So if I jump in the middle of that and just send it another certificate, it'll think that I'm the secure service, and it'll speak to me. So SSL strip can help you do that. And if the client doesn't raise an exception when it sees an invalid certificate, then you can intercept encrypted communication. So as far as the user's concerned, I've got SSL here and I'm fine, but you're still man in the middle and underneath them. And Snoopy is a fantastic tool. When you search for it, don't just search for Snoopy, because you'll just get pictures of a dog. Search for distributed tracking Snoopy, and you'll see this little device that some of the guys in the UK have built, and they just drop it around wherever, and it acts as it sniffs Wi-Fi connections, anyone coming in, and it pretends to be a Wi-Fi access point. And then you can connect to it, and you can go out to the internet, but it sends you through a proxy server, and they log everything you do through that proxy server, and they also track your movements. So they dumped a whole bunch of these around London, and then tracked themselves on GPS, moving around London and where they went. So not only was it getting access to the data, it was also getting access to the person's movements, and because of how they set it up, they managed to get the Twitter account and the Facebook, so they knew the name of the person. They could identify the person, tell you who they are, hack into their account, and you knew exactly where they were. So if you were, If you're worried about your personal privacy, you know, you've completely lost it there. And the reason that it was so useful is because mobile phones are very loud. They search for wireless networks. They're constantly sending out beacons. You've got Bluetooth, and you've got NFC, and you've got wireless, and your phone's saying, look at me, look at me, look at me the whole time. And if you're not switching these things off, then these tools can capture your information. Which is why my device has everything switched off, Bluetooth and wireless and everything. I don't switch it on. And when I go to security conferences, generally I speak to security people, not when I present, not to developers. Everyone in the room, as far as I'm concerned, is an attacker to me, so I just don't take my phone. I just switch it off. I'm that paranoid, I just won't do it. I won't take my corporate device. If I go to Black Hat, I'm out of office and you can't contact me. I will not be using any wireless in Black Hat because people are out there with vulnerabilities in GPRS, vulnerabilities in GSM, knocking devices over. And I've seen devices fail very oddly because someone's attempting to do that at DEF CON and Black Hat and these places. So what do you do about your data in transit? What's your threat? Your threat's someone eavesdropping. They could be listening to your communication. And how do you protect it? Generally, it's one of these two options. There's other things you can do. The most common is SSL, HTTPS. If you're doing an application that's a front end to a web system, then SSL is pretty common. But I have a presentation that's about an hour and a half long on how to get SSL wrong, what the issues could be. SSL is not a case of just switch it on and you've got it. There's a whole bunch of security vulnerabilities that you could have in your code, even though you've got SSL there. And I've been around internally in BlackBerry teams telling people how not to do this, because I get it on a daily basis. We sit down with the development teams at the design stage and say, okay, well, how do you protect data in transit? Okay, we've got SSL. That's good. How do you deliver your certificates? Oh yeah, you just go to a HTTP website and download it. Okay, so you go to an unauthenticated website and an unprotected website and you download the certificate. What if I attack you at that point and I intercept that communication and I send my certificate to the client? Okay, we've got a new problem. We've got certificate delivery. The web browsers solve that problem by having it as part of their installation. But if you've got an application that has to be loaded on a device and it needs its own custom SSL, it's not using VeriSign or another CA that's on our device, how do you get your certificate down there? Does it come in a bar file? Does it come from another area? How does it recognise your service? And then you've got the revocation of the certificate. What if someone steals it? What if someone gets access to your private key? DigiNotar were a CA, Certificate Authority, and they had their private key stolen, which meant that the SSL across the internet was pretty much broken for a few days. And that affected us because we had their certificates in our systems. So we had to revoke certificates. And for some of our teams, it was the first time they'd had to revoke any sort of certificate. So they had no process for it. They didn't know how to do it. So guys like Bez, it's fairly easy. But some of our smaller development teams had no idea what to do. So we had to kind of walk them through the process. So just having SSL in place doesn't solve the security problem. You've still got issues that you can get within it. And when you're implementing that, you need someone that understands SSL to help you with it, because it's a very complex protocol. It's not as simple as it seems. How do you know you're being listened in on? If you have an unencrypted communication, there's no way. You just can't see it, unless you want to get into quantum theory, which is another fantastic presentation. But you might notice certificate errors, and you might ignore them. If you have a BlackBerry, you'll get the continue stop error coming up if you try and connect to a device. If you connect to the Wi-Fi here, the hotspot login, if you try to go to Google's website before hitting the hotspot login, it intercepts your communication. You get a certificate error on that because the hotspot here is attacking your communication, right? It's taking you away from Google. You're not going to the website that you think you're going to. You're going to the hotspot. So they're doing it here for legitimate reasons. But if you're seeing those errors for illegitimate reasons, then you need to consider the security implications. And how do you know if it's legitimate or not? Like I know what's a potential security issue because I look at security all day. But like if my mum seen that error on her device, continue stop, this is an insecure connection. I don't know, I'll hit stop and then it doesn't work. She can't get to her web page. Okay, I'll try again. This time I'll hit continue and I'll go through. She doesn't know. And so one of the security challenges is making security decisions for the user very easy, so they know what's a security problem and what isn't. And we spend a lot of time looking at the user experience with our products and thinking about how you present this information to the user. If you look at the certificate errors in the browser, if you go back to the early IE5 days, you just got a very cryptic error message, whereas now you get a very detailed, you get a very simple message with a little button to get more details, from the certificate, and you know why it's being rejected or why you shouldn't use it. And Chrome's the same. It has big buttons that say this is bad, you don't want to do it, but if you want to continue, you can. And here's the risks. You want to read about it. So when you're building this into your application, you've got that same problem. You have to figure out how do you alert the user to security issues, and then how do you respond to it? You've got certificate revocation. You improve your implementation. You get your SSL implementation looked into by someone that knows it and is able to find the issues, and then you issue new certificates. You get them out there, and you use your certificate revocation list to let people know that those are gone. So, final slide. Like we said earlier, the earlier in the process that you think about security, the easier it is. As you've seen, going along that line, that when you get to the restoring from backup stage, then something's seriously gone wrong, and that's going to cost you money and time and effort that you don't really want to have, which is why you want to put all this work in right at the very beginning. Don't let these vulnerabilities get into the product in the first place. Keep it in mind, keep it secure, and then you won't have to pay for it later on. And we have a couple of links up there. And the first one is the BlackBerry developer site. There's a whole bunch of security documentation on there that you can have a look at. Microsoft Security Development Lifecycle is where we get a lot of our inspiration from. They've gone through this pain a long time ago. Microsoft used to be the whipping boy for the security world. I built my career breaking Microsoft software. And now you can't do that. They have an excellent security team. They've got strong SDL processes in place. If you want to find a remote code execution vulnerability in Windows, it's not a day-long task anymore. It's months to a year to find a vulnerability like that. So if you're looking for an SDL process to implement, this is a good place to start, and a lot of our internal stuff is based on it. And then vulnerabilities, if you find vulnerabilities in RIM products and you think it should be fixed and you think there's a security issue, then email these guys, secure@RIM. That's the incident response team, my friends and colleagues, and their job is to basically deal with your requests personally. So we have, if you find a vulnerability, you'll be assigned a response handler, and they will talk to you on the phone and through email and figure out the issue and dig into the code, and then they'll go straight to the development teams and get me involved, and we'll get the fixes in if there's a fix is needed, or if it's not a vulnerability, we'll explain why. And those guys just sit and do nothing until these things come in. So they need some work. Find bugs, send it into them, keep them busy. And that's it for me. So we'll take some questions if we've got time. I don't know how we're doing for time. I've seen the 5. Okay. So we're.
I just checked the BlackBerry Z10 trusted certificates. I noticed Turk Trust is still in there.
Yes. Yeah, certificate handling is very difficult, especially on a device. Trying to get it out there and trying to get it fixed is a nightmare. And that's not when that fails. That's not a failing of our developers. That's another company's certificate problems. Affects us pretty heavily. Yep.
How quickly do you expect the Z10 to be rooted?
A good question. Hopefully not very quickly. I'd like to say that this device is unrootable and it can't be done. But we've done a lot of security work in the Z10. And we've done a lot of security work in BB10 in general. I've been looking at BB10 code for over a year now in various incarnations, and we've got guys today that only do BB10 code. They only look at the OS code and things like that, and we find ways to jailbreak it, to root it, and they get it fixed internally. I've no doubt that any device will have issues and they will come up. My hope is that they're few and far between, and that's the best you can ever do. You can never remove security issues completely. You can never do that. But what you want to do is reduce their frequency, reduce their numbers.
But your policy is to be against it if somebody releases an exploit.
Sorry?
If somebody releases an exploit, then you're going to fix it. You're not going to let it run.
Generally, yep. Depending on the exploit and how it works and what it does, yeah, we'll generally fix it, because sometimes the jailbreak is also a remote security vulnerability as well, and those are rated higher, and we worry about them a little bit more, and we fix them. But if there's a way to escalate privileges that's not by design, then we'll attempt to fix it. Okay, well, we'll be hanging around for the rest of the day, walking about with this big, lovely green T-shirt on. So if you've got any specific questions, or you want to talk about stuff in a bit more detail, then flag me, and I'll happy to chat. Thank you.